Consecutive numbers. Consecutive numbers would be numbers like, say, 4, 5, 6, 7, so on and so forth. Now we can write an algebraic expression to model consecutive numbers such as x, x plus 1, x plus 2. Garrett, give me an integer. Garrett gives me 4. If I plug 4 in, I get 4. 4 plus 1 is 5. 4 plus 2 is 6. If you choose an integer value for x, it will produce consecutive values. So the question is, how can you produce even numbers? Numbers that are consecutive and even. What can you do to any number in order to make it even? Add 2. 10 plus 2 is 12. Good. But 11 plus 2 is 13. Not even. Very good. Take any integer, multiply it by 2, and it will be even. So what's the next one? Very good. 2x plus 2. 2x plus 4. Consecutive odds. Now that I made a number even, what would I do to an even number in order to make it odd? Close. X plus 1 and x plus 3, this works in some scenarios. For example, suppose x was 4. Then you get 5 and you get 7, right? But suppose x was 5. Then you get 6 and you get 8. So those are not odd. Three x plus 1. If you try 4, you get 13, right? If we try 5, we get 16. What's that? Divide by 2. 8 divided by 2 is 4. 9 divided by 2 is 4.5. 10 divided by 2 is 5. So you can see that one of those gives me an odd, but not all of them give me odds. Think, folks, we made something even. What could you do to an even number, any even number, in order to make it odd? Times 2 plus 1. So 2x plus 1, 2x plus 3, 2x plus 5, so on and so forth. Those will give you consecutive odd integers. Watch. Brooke, give me an integer. 6. Brooke gives me 6. 2 times 6 is 12, plus 1 is 13. 2 times 6 is 12, plus 3 is 15. 2 times 6 is 12, plus 5 is 17. So you can see that they are producing consecutive odd integers. So the first question is, find 4 consecutive odd integers whose sum is 80. So we got this actually as a question. Somebody was here giving a speech for a graduation a while ago, and they proposed to the whole audience, what are 4 consecutive integers whose sum is 80? It was interesting to see the different kind of math going on in people's minds. Most of the math teachers came up with it pretty quickly, and our way of doing it was simply take 80 divided by 40 and 20. And we knew that 20 was not, in fact, an odd number, but we simply went to the side of 20, 19 and 21, and then 17 and 23, and we came up with 4 that do add to 80 that are consecutive pretty quickly. Okay? Now, the fact is that's what we call guess and check method. Now, you're not going to use that. And in this class, for this test, you need to model it with an equation, because that's what we are trying to do. We're trying to model with equations. The more you can take mathematics and model it with equations, the better mathematician you're going to be. And you won't be able to guess and check a problem like 14. That ain't happening at all. So if you guess and check, I'll give you maybe a couple points for your answer, but you need to model it with an equation. So here's what I write. I write 2x plus 1 plus 2x plus 3 plus 2x plus 5 plus 2x plus 7. That all adds to 80. That's an equation that models the problem. How many x's do I have? 8x plus 16 is equal to 80. Subtract the 16, 8x is equal to 64, and divide by 8, x is 8. That my answer? Why? Yeah, that's simply what's going to generate the answer. x equals 8, I plug that back in. 2 times 8 is 16 plus 1 is 17. And then from there, it's easy to generate the others because they are simply consecutive. That's my answer. Find 2 consecutive squares whose sum is 613. You see, when we do these type of problems, it's easy when you've seen one that I've already laid out for you. My guess is I could ask you sum of consecutive integers now, you'd be fine. But what about consecutive squares? Can you model 2 consecutive squares? Good. 9, 16. We want to model them with algebra now. So if this one is x squared, what is that one? They have an orchestra thing. I offended them. I was talking about perfect squares. They don't believe them. Nine is 16. Shelby says an example of 2 consecutive squares. She's correct. So if I say that 1 square is x squared, what would be the consecutive one after it? Very good. So again, I could give you all the pieces. The question is, what if you encounter a problem someday where I haven't modeled that exact thing for you? Are you going to be able to come up with some of it? And being able to come up with something on your own, that's really, really an impressive part. So I'm going to give you that opportunity later on this year. Some of you will be ready to pull your brains out because you're like, I can't do it unless you show me how to do an example. Eventually, the hope is that you could do the problem without seeing a straight example for you. So look at how this works. Look at what Shelby did. She said that this is 3 squared. This is 3 plus 1 squared. This is 3 plus 2 squared. So in order to get the consecutive one, you take x and you add, something to it and then square it. So when it says find 2 consecutive squares whose sum is 613, the first square is x squared. The next square is x plus 1 quantity squared. And when you add those together, you get 613. That's an equation that models the problem. X squared plus, and by the way, I still get this, folks. We have to somehow get past that. You get somehow, folks. We got. I mean, it's okay that this is like a slip of the mind, like you make a simple mistake, but we got to get past that point where we actually think that those two are equivalent. Okay, we've got to step into this world. X squared plus 2x plus 1 is equal to 613. Our x squareds make 2x squared plus 2x. And when I subtract the 613, I get negative 612. Because we know we want to set it equal to 0 to solve. Now, my guess is that factors, but my guess is that nobody here probably thinks off the top of their head exactly how that factors. So wouldn't it be nice if we had, I don't know, maybe like a formula on our graphing calculator that people watched a 4-minute, 2-second video for and plugged it in where they're able to figure it out? Okay, so I've got 17 and negative 18. And that's my answers, right? No. What do I do with them? Plug it in. Should I plug in the 17 or negative 18? Are you sure? Well, I like your thought about trying them both, because most people just say choose the 17 because you can't use the negative one. Very interesting if you see what happens here. If I plug in 17, 17 squared is 289. And then 17 plus 1 is 18. Squared is 324. Those are consecutive squares, and they do add up to 613. So that is correct. Those are my 2 squares. What's interesting here is Carson says, well, why not just plug in the negative 18 and see what happens? What's negative 18 squared? 324. Negative 18 plus 1 is negative 17. Squared is 289. I mean, math finds 2 ways to be able to find the answer. You can see that consecutive, forward or backward, however you're thinking of it. It's pretty impressive how math finds two ways to find those solutions that we weren't even really thinking about. So they both work. You got 289, 324. They both technically give you the same result. Flip it over. Rectangular garden has perimeter 288. Length is 4 more than twice the width. What are the dimensions of the garden? You've seen this problem before. You should be able to walk me right through it. What do you want to start by doing? Draw a picture. Great. Now what? Okay, that's one thought. I'd like to start a little bit more basic. I just like to write down some labels. How's that? What do I do with that? 2w plus 4. Now what? What's perimeter? What is perimeter? All the sides added up. How many sides are there? There's 4. So w plus 2w plus 4 plus w plus 2w plus 4. So 288 is equal to how many w's? 6 plus 8. 6w plus 8. Or 280 is equal to 6w. Divide by 6. And we should get 46.6 repeating. Have we answered the question? What do we need to do to answer the question? For what? To determine what the length is. So W is equal to 46.6 feet. And the length is equal to 2 times 46.6 repeating is 93.3 repeating. If we add 4 to that, we get 97.3 repeating. I'm going to do 2 more problems. Oh, how about, you know what? How about we just take it and throw it in the garbage? Huh? How about we just do that? My box doesn't mean anything to you. All right, here we go. So, it's going to be made from a square piece of cardboard. We're going to cut these 4 inches off the side. So when I fold those sides up, it says I can be left with a square base, correct? I'll call it x by x. I'll draw a 3-dimensional view of what it would look like if you folded it up. So now what? I need an equation. Something. What does that mean? What kind of measurement is that? Volume. Do we have a formula for volume? Base times width times height. or length, we should say maybe, times width times height. Which of these variables do we know? Do we know the volume? Yeah, it's 100. Do we know the height? Yeah, it's 4. Do we know the width or the length? They're the same, right? Can we solve that? Yeah. 25 is x squared. So x is 5. Is that the answer? What's it looking for? How big the original piece of cardboard would be. So if x is 5, how big is the original piece of cardboard? Yeah, 4 above, 4 below, 4 across, 4 across, so 13 inches by 13 inches. Last problem of the day. This is one where you should really be able to walk me through basically the whole thing. You really should. Okay? Right triangle is the hypotenuse of the length 12.5. One leg is 8.5 inches longer than the other. What is the area of the triangle? Where do you want me to start? You guys are leading here. Draw a picture. Okay. What? Label what? What's the hypotenuse? Okay. What do you want me to put for the sides? X plus. Good. Now what? What equation? What? We're asking for area. Good thought. Fortunately, that does not work out. You've already said the answer once. I got to find x, right? How can I find x? Pythagorean theorem. So you can see that if we use x squared plus x plus 8.5 squared is equal to 12.5 squared. That's going to allow us to solve for x. So I have x squared plus, I'm going to get another x squared. Anybody know what I'm going to get in the middle? 17x. And then 8.5 times 8.5. 72.25. 12.5 times 12.5. 156.25. Second degree equation, I should make it equal to 0. 2x squared plus 17x. I subtract over, I get minus 84 equal to 0. Oh man, quadratic formula. Wish I had it in my calculator. Wish somebody would make me a video, like maybe a video that lasts 4 minutes and 2 seconds. All right, Laura offered up to us her calculator, which she has programmed it. We get 3.5 and we get negative 12. Which one do you think we use? Try them both. 3.5, and this would be 3.5 plus 8.5 is 12. Can the sides of a triangle be negative? Not in this world. I was hearing a news report this morning about how scientists believe that like if you spin an electron on its axis that you get these alternate worlds that come up. Whatever. So maybe in the alternate world we have negative 12 for x and we have negative 3.5 for over here. Maybe that works. But in this world it doesn't. So we have that. So we can now calculate the area. The area is 1/2 times 12 times 3.5. And 1/2 of 12 is 6 times 3.5 is 21 inches squared. That's a good problem right there. All problems that you are very capable of doing. I'm going to hand out your assignment.